third purpose for problem string. What if I want to reinforce the learning that's been happening with a twist? So let's take a look at this problem string. So I might start with x squared. And I might, don't look at what's, I have no idea what's up on my browser right now. None whatsoever. I'm going to go to Desmos. And it's a free online calculator. If you don't know about it, ask me later. We don't have time. So, phenomenal tool. We built it into, it is our platform of choice in discovering advanced algebra, discovering geometry. Can I announce that?
I think so.
Stay tuned. I think they signed the contract yesterday. Okay, anyway. So embedded in the ebook are all these simulations, and the data's in there, and you can open it up in your class and display, and it's all sitting there. Really cool stuff. But you can also just use it as a graphic calculator. So I can say to kids, y equals x squared. What do you guys know? And they could tell me what they know. We can put a couple points. I could turn this on projector mode so it looks even nicer. You can see a little bit better. And then I could say, what would happen if I took that y equals x squared? Pardon me for just a minute. Cheat sheet. No. And I, instead of graphing y equals x squared, I replaced x with x minus 200. Then I squared it. I replaced x with x minus 200. Then I squared it. What would that graph look like? Where would it be? And what would be a good viewing window? Where can I go find it? Now, if kids are on an iPad at this point, often what they'll do is go, because you can do that with Desmos, which is actually quite cool. So I have to add this little stipulation if they're on any kind of a touch screen that I have to go with as few moves as possible. What can you, like, don't go hunting and pecking for it. I want to actually think about what I know. So I would have, remember this is the reinforced string. This isn't the teach for the first time string. This is the reinforced string. So kids have already learned about horizontal translations. So I say to them, based on your ideas of transformations, where would it be? Okay guys, where is it? So what window would you change? What would you change, the x's or the y's to go find it? How? I need to go to the right? I need to go to the right. How do I go to the right? What number do I change? The minimum or the maximum? So I could maybe stay at negative 10 if I wanted to, but I'm going to go over here to maybe 210. Hey, look at there. There's the first one, and get that rid of that, and there's the second one. Now, do you like that viewing? Now I just drag. Do you like that viewing window? That's not. It looks like could be absolute value. Like I'm not. So I would want to create a better viewing window. How could I change that to create a better viewing window? So real quick, I could do that. Instantly, I've gotten rid of some extra space. So defining a good viewing window is a little tricky. It's not about the viewing window. It's about something that shows the important aspects of the function, and I don't have a lot of extra space. You would establish that at some point. So how else would I change that so that I see more of a parabola and less of a whatever that is?
Make the minimum 190.
Make what minimum?
The XX.
The x 190. What about the y? Or the maximum? Keep it at 210? Hey, that's better. Could we then keep messing a little bit, but messing with the window, not the stretching and shrinking and stuff, but thinking about where it is, and not spending too much time on it. What if I then said to you, okay, fine, what if the new function is y equals x squared, but this time I'm going to subtract 750. Now, sometimes the reasons for the big numbers is so that if they are swiping, but I'm ignoring you, they're swiping for a while. So then I get to talk about efficiency, and I get to go, come on, can we be efficient here? What would it be? Where could I see that guy? Now, we're probably not going to be able to see all these in the same window, so I'm going to turn the other two off. I'm going to go back to the home sort of view. There, I'm kind of back where we started. Where am I going to look for that guy? What are you guys going to tell me? Yeah, where? Am I going to change the y, this guy a y or that guy a y? You need to see the cursors up there. The minimum to what? Almost here TI users. To what? 7 what? 760 somebody suggested. Hey, okay. Can you I know it's, if you're sitting, can you sort of see it? Like, sort of see it? So what could I change to make it look more like I was sort of expected to change? Could we mess with the Y max? And I don't want to spend too much time on this. I hope I can give you a little bit of an idea. So when I began teaching, what are you going to change it to, by the way? Negative 730? Negative 740? It's fine. I agree. Not great, but it's fine.
It'll work.
We can stop right there. When I began teaching, I taught with DeMann and Waite's first textbook. I don't know what it's called. They were the grandfathers of graphic calculators. I learned so much from what they wrote. In every Blumen section, they would have, find a good viewing window for. And I would be like, oh, that's like number 2. I skipped that one. I did, like of 1 through 39 odd, I did 37 and 39 to make sure I knew, before the kids had questions the next day. Next day in pre-cal, the kids are like, 2. I'm like, 2? The question of number 2 was 100 square root of x. Find a good viewing window. It took us a half an hour. My sense of functions and transformations at that point, that was a few years ago, was so bad, I had no idea where to look. Nor did I have any numeracy to think about even how I would open that window. There's your homework for today, 100 square root of x, find a good viewing window. Could I then finish this problem string with just some other functions like it, where I'm literally just saying to kids, so we just did that one, where would that one be, where would that one be? Not rocket science, but I'm just sort of solidifying this idea. Could I have, in fact, I'm not even sure why I didn't do this. How come I don't have both a horizontal and a vertical in one of them? Lame. I'll fix that one. So this one should have, in fact, probably maybe here I would have, it depends, right? At this point, maybe I put an asterisk by this question and an asterisk by that question, meaning optional. So if we do the first one and kids are like, I have no idea where it is, well then maybe I keep the optional problems and like, all right, are we good with the replace is the horizontal and the add on the end, the whole function and values, that's the vertical, cool. Then I would add 2 at the end where I'm sort of combining. And then I might do something like this, where I add a different parent function. And I say, okay, for that new parent function, no, a little bit less. For that new parent function, what about these transformations? So anybody that's ever done transformations with exponentials knows there's like a surprise that happens because the anchor point is no longer 0, 0, right? And so now the anchor point doesn't have a y value of 0. And when I start scaling that anchor point, what happens to it? Ooh, there's something for you to go investigate. So when I start graphing 2 to the x, it goes through what point? 0, 0?
0, 1.
If I have help me, what are these? Exponential function, it goes to the point 0, 1, because any number to the 0 power is 1. We define it to be that way. So then if I multiply that 1 by something, that second guy is not just going to stretch. If you're an algebra 1 teacher, you're like, yes it does. No, it doesn't just stretch. It actually stretches the y-intercept as well, right? So that would be something that I can sort of solidify using this problem string. So I give these problem strings are strings of problems that I give one at a time, which is kind of like not how I'm doing it so much today with you. I'm doing it with you as teachers. One problem, solve, we chat about it, I model thinking. Another problem, solve, we chat about it, I model thinking, I draw out relationships to the problem before. Another problem, solve, chat about it, I model thinking, draw on relationships. I start to perk ideas of things that could come up later. So that by the time I get to things down like that, I have some idea. Notice how I kept 2 to the x, 2 to the x. Then I changed 5 to the x. All right, now we're going to mess around with different bases, not just different transformations to see what happens. So that could be another example of reinforcing with a twist. I think finding good viewing windows is a relatively, oh golly, how do you say it? Well, error, when low cost of failure. That's what I was looking for. Finding a good viewing window, you can just mess until you find a good one. Then the teacher needs to say, yeah, but how could we have used our knowledge of transformations to think about that? So it's very low threshold. Kids can mess, and then I can help abstract out and make sure that we're clear on why those guys are all working out.